First of all, thank you for joining this talk, and I hope you'll take away from it a lot of practical hints and ideas to apply to everyday projects. Be warned that this is not a soft skill presentation. This is a very hardcore technical stuff, so be warned. I promise a headache. Pay attention here. It's hardcore stuff. Good. So let's get started. Let me introduce myself. My name is Victor. I'm from Romania. I'm a Java champion. I've been coding in Java for quite a while. And right now I'm doing consultancy and training for different companies throughout Europe. These are my favorite topics: clean code architecture, unit testing, of course, frameworks, secure coding, and performance. I gave a lot of talks at different conferences. You can find dozens of them on YouTube. But what I want to tell you more about is the community that I started 4 years ago, which has now turned into the world's largest community on software crafting. At which point you say, software what? Software crafting. Basically, clean code architecture, unit testing, and getting better as professionals. What happens in this community? Every month we meet 1 hour after hours for an online event, in English, of course. And we debate different topics. It's a very engaging environment, more than 100 people live joining and a lot of debate in there. So I will invite you all to join. There will be a QR at the end. Feel free to scan it, completely free, of course. If you want to have a look, the many events that we did in that community are recorded on my YouTube channel. Outside work, I'm a father of 2, owner of a cat, although better said, the cat owns me. And I'm trying to get away from screens during weekends, doing some gardening. All right, let's turn back time for a bit, down to the dawn of Agile, in which they were talking about a concept called emergent design. That while we keep shipping working software, the design, the architecture will naturally evolve by itself, magically. I'm not sure about you, but what I've seen in many teams, that emergent design never emerged, and we ended up with software like this, continuing to ship shit every day. You know, people need triggers. People need to be kicked in the ass. Hey, you need to improve the design. You can't just expect they will naturally improve. That was a dream, you know? And the missing piece, what was lost since that day, and why this didn't work, is that we forgot about one of the most important ingredients in Agile: testing. Tests will give you the necessary kicks and hints to improve the design. And that's the purpose of this talk today. I want to introduce you to my favorite guy, to my favorite IT guy, Kent Beck. I'm not sure who knows Kent Beck. Kent Beck. Oh, a quarter of you, too few of you. My God, this guy made IT. This guy created extreme programming, the most technical form of Agile back in the days. This guy, he invented TDD, created JUnit, and basically is the father of unit testing in general. This guy is God. He's like the apostle. And back in the days in extreme programming, he introduced a series of 4 laws for creating simple design, because nothing is more sophisticated than coming up with a simple solution for a complicated problem. Da Vinci, approximate quote. So here it is, 4 rules of simple design. The first rule, it passes all the tests. I know many teams that will stop right there, but how else? How else can you prove that it really works? And what? If you have those tests behind you, tomorrow if you find a simpler solution to the same problem, you won't hesitate to change it. If you don't have the tests, it works, don't touch it, right? So you have to have tests, first of all. Then, you want to have the code as close as possible to the domain. Talking the same names, playing all the clean code book, all the principles, all the hints that you can. Of course, then don't tolerate duplication. And the 4th rule, you should not put anything except those to fulfill the above 3 rules. And these are intentionally equal in power. Now, what Kent Beck wanted actually to say, but I figured out after 10 years of discussing about this, he wanted to say that the moment you write tests, you get a huge amount of design feedback. So if you try to write tests and your tests are a mess, it means your production design sucks, and you knew that. You knew that, I'm sure. So let's turn a bit time back to see how the world looked 2 decades ago. What is this? What is this shape? What does it sound like? It's an Ice cream cone, thank you, exactly. Now, this is the famous ice cream cone testing anti-pattern, in which they hired 30 manual testers. They barely had some coverage using end-to-end automated Selenium testing, no integration tests, and they were just starting to write unit tests. What are those? This is the reality in many legacy monoliths today. Your life depends on systems that are tested like this. Your life depends on systems that are tested like this. So let's turn this cone backwards, and then now we get to the testing pyramid. The problem with this approach is that it didn't grant us much safety to change the code, didn't it? I mean, like, you don't get much coverage with such tests, and it's painful and expensive. It doesn't scale with time. Now, who of you has ever heard of the testing pyramid? Come on. I expect, yes, basically all of you. Now, this testing pyramid, I don't need to explain that from the bottom up, you test larger and larger chunks of code. So at the bottom, you just test a slice of behavior, a very thin slice of behavior, where at the top, you put everything up to test basically critical business flows. The tests at the top are supposed to prove that the stuff really works. And there are teams out there. Does any one of you runs test in production? Test in production, continuously trying to check whether I can still check out the product. This is as far as it can go, right? Testing in the real thing. Now, down at the bottom, there are those deep corner cases that it's very hard to get through the API. So that deep edge cases. Now, two details about the pyramid. It's a pyramid because it's supposed to be overlapping. A test on the end-to-end is supposed to be retested. That code that you tested with a test from above, it's normal to be retested with tests in the other categories, of course. And also, one hint that some people missed, the surface of these shapes is proportional to the number of tests in that area, of course. Let's get us on the same page first. Now, mocks. One word about mocks. Because when we live in unit tests, because this is where we are supposed to live, in unit tests, and mocks are a dear old friend. Friend? Exactly. Not sure about at the beginning of our career, we all love mocks. And for good reason. In one sense, they allow us to test our stuff without depending on external systems. And that's a really big deal. However, nowadays, back in the hallway there is a booth that talks about test containers in cloud. So we found other ways to isolate our tests from other systems. We started embedded systems. We started Dockers containing the resources we need, or WireMock to emulate the responses of third-party APIs. So we don't really need mocks to isolate our tests anymore. Now, the one point that mocks really shine in, the undisputed leader in this field is they are super fast. You can't beat a test using Mockito that doesn't start any container, doesn't talk to any database, any Docker, nothing. You can't beat that. You can have hundreds, thousands per second executed. So that's the undisputed. You can't mess with that. That's super cool for mocks. However, why many people go to mocks is to be able to test just the bit they wrote, just the slice of functionality they've added to some code. Because test the whole thing is too complicated. And there are some people out there who believe this is cheating. Now, this is a very controversial piece of paper for you guys. If you want to, look how this reads. Why most unit testing is waste. What is this? Anarchy. It's not a paper for children. The slides I already tweeted the slides just before the talk, so you can find them online already. Good. Now, of course, there are good reasons, moments in which you can't really test the whole thing because it gets too complicated to test everything. Just a short sweep through this code. The for needs a dedicated test. The if inside, one more test. The for inside, one more test. And then, guess what? This if is composed of 3 conditions. One test for each. You see, so the more branches you have in your execution, the more tests, of course, you should write. Now, in terms of code complexity, there are today 2 mainstream techniques to measure it. Cyclomatic complexity for ages and cognitive complexity that Sonar measures in your code. Both of them will give you an idea of how many tests you need to write for a certain piece of code, like how many approximate. But imagine now 2 functions, one having a complexity of 5, the other having a complexity of 6. If you want to test both f calling g, how many tests would you require? 11? There are 5 branches in A, 6 branches in G. How many in total? 30. In the worst case scenario, 30 tests. Yeah! 30 tests. Oh, yeah. Now, so trying to test A plus G together at some point becomes unreasonable because there are just too many branches to cover, too many tests, right? And I'm throwing a test in a legacy code base, right? To push your test through your spear through that code base, you need a lot of data for all the 11 branches, the 11 inflection decision points on the path. So the data you need to throw at such a test is large. So at some point, mocks are inevitable. You can't just escape mocks if you are implementing a non-trivial system, right? However, after a while, in our career, many of us realize the weak points of mocks. The fact that despite having thousands of green tests on Jenkins, when you put it in production, unit test, please, and now integration test. Integration test. Amazing job. Or my personal favorite, this one. Look, this is production. Production! But now look, the umbrella opens, so the unit test was green. You see, what does this try to tell you? You might have slip bugs in production despite green tests. And you've seen that, and it's super frustrating, right? Next thing, you will end up with tests, and I'll explain why, that would break any kind of refactoring you attempted on your code. Anything that you want to change, boom, 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 and I'll explain why, right? And the third point, why we hate mocks is that tests with heavy mocking end up unreadable. Have a look. Mock, 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 mock. Amazing job. So we are testing mocks in here. What the heck is happening? And then here comes the test. Anonymized from production of a client. What the heck is going on, right? And you are entitled to ask, what the heck am I testing here? And you know the fun thing here? What you were testing with that test were 4 lines of production code. 4 lines of production code and 20 lines of a test. What the hell is wrong with you? You are supposed to ask a question in this moment, right? So I met people who told me that they will just simply delete the unit test because claiming that no one can actually maintain this. I'm going to burn it myself, right? This is useless. I can't tell you that in this talk. That will lead to anarchy. So look, what I'm telling you instead is to try to maybe simplify the production. This is another snippet of a production code that you might want to test. Please, I beg you, do not unit test this in isolation with mocks around it. Doesn't make any sense. But instead question, who calls G? Is it a controller? Can't I just blow up G and inline the method to wherever it's called? If it's called from a single place, do it. You just got rid of some useless boilerplate code. It's called a man in the middle, inline man in the middle refactoring. It's just useless code. That's one solution, but you might not have the power or willingness to change the architecture like that. So instead, you could take a step back and try to test the whole thing together without any mocks. And that is now known as the honeycomb testing. You see, the pyramid that we described before, that came from the age of monoliths. That was designed when systems were hundreds of thousands, millions of lines of code, right? In a monolith, in a good old monolith, you have just several APIs hiding terrible amount of complexity. Getting to test all the corners of the 10,000 lines of code flow called place order, getting to all the 10,000 lines of code, it's impossible by just testing the API. Of course you want to white box the code and start dissecting stuff inside. Of course, it's natural. However, accumulating that amount of complexity in a microservice or a modular monolith is a bad practice. You need to break that complexity into pieces. So where does this lead us to? To more APIs, more testing surfaces, and less complexity behind each of these testing surfaces. So, introducing the honeycomb testing strategy, which is becoming more and more mainstream. I mean, I'm seeing this in many companies that I get this wonderful luck. I get to talk to very bright people from many, many companies. So I get to learn a lot myself from the sessions I run. At the top of this hexagon, there are the same integrated tests, putting everything together and practicing, exercising everything. At the middle, however, this is the difference. The surface of the center area of the integration test is larger to tell you that I want to test every flow with integration tests, starting up the whole microservice and firing up tests of the API to go everywhere. And I will struggle to do that as much as I can, with all my power. But there are two problems in here. The number of tests and the size of these tests over here can go wild. They might lead you to create a testing DSL, a testing framework. And the interactions with the outside world, but we have a solution for that, don't we? We can wire mock and test container those, and you're done. You can have back your isolated tests, but without employing any mocks in the code. Just test the whole flow from the API 100%, basically. However, there will be use cases, flows, that you would run into some terrible amount of complexity every now and then. When this happens, decouple that complexity out and fall back to implementation detail tests. Cut that naturally isolated part of the code with high complexity and fall back to unit tests, to implementation detail tests. But that's not the starting point anymore. That's the change in mindset. You start with end-to-end flows through the whole microservice, integration test, as they call it. And I'm not making up this myself, my friend. This is Spotify. So I'm not, hey, look what I thought last night. No, that's becoming a mainstream technique in many of my clients. Now, integration tests are all you need to test manageable complexity. If an endpoint is, okay, you could survive by not having a single unit test, a single test using mocks, but with no mocks. However, the interesting part goes, any complexity gets accumulated and tested here in the implementation detail. And in that game over there, you will get a lot of design feedback. What's the difference? If you test black box, the whole thing using integrated tests, you can have the wildest jungle inside the code. I'll tell you a secret. I don't care. I don't care. If it's a medium average complicated flow, I don't care how you wrote the design. The problem is in that terrible part of complexity, how you tackle it. So that terrible part of complexity will be tested by implementation detail tests, and that will give you the most of the feedback. So for the remaining of this discussion today, I will focus on tests there at the bottom of that hexagon in the implementation detail. And let me get back to mocks. 2004, right? Some guys here in UK working at ThoughtWorks were just discovering mocks. They were inventing mocks. There were no mocks before, and they wrote a paper. Have you ever seen a format like this with abstract? Anyone have seen that before? Like if you did a PhD or a master's degree? What the heck? They wrote a scientific paper. Who does that about mocks? Really, now, without any... If I would invite all of you that are using mocks in your tests to read this from to the last character. It's full of best practices and pitfalls in using mocks that they saw 2 decades ago. But the title is the most confusing. Mock roles, not objects. What the heck do they mean by that? Mock roles, not objects. I'll explain with an example. Let's imagine you implement a feature, a new brand feature. You click, it works, congratulations, party, and then I forgot about tests. The next thing you do, you write tests. How do you write tests? By copy-pasting all the dependencies that you had in the production code. Mock, everywhere. Like the test that you just saw. And then, years later, you complain your tests are fragile. Anything you refactor, it blows up. Of course it blows up. That's the bad practice they were trying to tell us about. Don't just mock random objects. Try to reason about responsibilities and roles. I know this is pretty vague, I know. In the full detail workshop, we have lots of examples, but here I'm trying to take the idea from it. It's about thinking in terms of contracts, not just random methods in different objects. It's about, why? Because the moment you put a mock on a method, if you ever change that method, if you add a parameter, rename the method, break the function in two, God forbid, many tests will go bananas. Like, the moment you put a mock on an API, look at that method and wonder, is this a sharp responsibility? Is this doing exactly what it should be? Can I name it? Is it sound? If it makes sense, go ahead. Do not rush to put mocks on immature methods, because then you will suffer if you ever change your mind about that. What am I talking here about, really? I'm talking about stopping to write solitary unit tests and instead go for a thing called social unit tests. What does that mean? Two classes tested together. Don't put a mock in between. But instead test them both. Maybe, of course, they will have external connections. Mock those. But these, test them together because they together fulfill a well-defined responsibility. So think in terms of responsibilities, not just random objects that you run into. Social unit tests, that's the idea here. Okay, and then tomorrow, if you change your mind about the internal implementation of that responsibility, nothing would break in the test if you decide to merge these two and break them in three. It gives yourself freedom because the responsibilities shift slower than some random methods you've thrown in the code because it's Friday and yeah, all right. And this leads us to another question. What is the unit test? If you ask a developer, most of people that I asked this question, they told me that a unit test means mocking all the dependencies of a class. Wrong. Wrong. This is stupid. This is bullshit. No. Unit testing means to first identify what the heck is going on. What are the responsibilities of the code? And then if a responsibility is implemented by 4 classes, suit yourself. A unit test covering 4 classes. Think in terms of roles, not just classes. Okay, now, how to put that? The honest mode on. I know it's hard. You have to put just an if in that method in the corner. Of course, it's so easy to just mock everything around and test the if. Bad news, ChatGPT can do that. Congratulations, you are competing with an AI. The point is to think of roles and clear responsibilities. I'm not sure if ChatGPT will ever be able to do that. Right? Oh, if you ever heard of diff blue cover, anyone? Diff blue cover can generate shitty tests to get you 100% coverage for the management. God forbid you open those tests. I'm like, oh my God. Okay, let me. Now, I split the hints that tests give you in 3 categories. The first one is about how they help you simplify methods and basically structures. First stupid example. It's good to start with something. A method takes an object with 15 fields, but it only uses 2 of those fields. You might not realize what a shitty design you did in production, but then you start testing that. And you wonder, what the heck am I creating big object to set 2 fields and pass it in? And if you do this thing 10 times, perhaps it will click. Perhaps. Some people don't click. But some people click. What the heck am I doing? Why am I instantiating such a large? Why can't I just pass 2 parameters to the freaking function? Welcome to clean code. A function should take precise, exactly the data it needs, not extra. 13 more fields, for what? Now, for more complicated scenarios, if there is heavy complexity inside this method growing larger and larger and larger, you have another opportunity. You might have another idea to introduce a new class to group together A, B, C. Why would I do that? That's called parameter object. I would do that only if there is terrible complexity hiding inside here. Right? It's not an easy decision to introduce a new class, right? But sometimes it pays off. 2 warnings on this slide. I don't know you guys. So let me put that on the screen. Do not ever mock getters. Do not ever mock getters. We mock behavior, not data. We instantiate data and pass in. Please, I beg you. Anyone doing domain-driven design with aggregates? Domain-driven design once, domain-driven design twice, except you guys. The rest of them do not mock getters, ever. Do not make mocks returning mocks. Please. And then don't laugh. You can't imagine the horror tests I saw, like, yeah, mocking every getter, and then a getter returned the mock, whose getters were also mocked. Yeah. Don't do that, please. All right. Now, some of you could probably think, maybe they are still stuck here, asking, Victor, what is this? Are these setters? Mutable data in 2023? Are you nuts? Setters? I'll get to that in a second. For now, next, I want to introduce you to a concept. to the concept of constrained object, for lack of a better name, which means objects that when you try to construct in an inconsistent state with incorrect data will throw exceptions at you. In the constructors, in the setters, everywhere. And there are two types of such objects, mutable or my favorite, immutable, of course. If you know that book, it clicks very well in your brain. Now, imagine such a constrained object grows very large. If it's very large and it wants to have all the data valid, that means it has a constructor like with all the necessary fields. Not fun to call such a constructor. So the test will become cumbersome to write. Instantiating data will become a mess. That's one scenario in which creating test data becomes horrible. The other scenario is when you have a social unit test or integration test that wants to go through a large chunk of code. So if you want to test an entire group of classes with a social unit test or an integration test full end-to-end, you will have to provide heavy data inputs. That being said, I'm sure if I open your code bases that all of you, or most of you, have a class named test data or object mother, of course. Why are you laughing? Is it that ugly or what? A large class that creates objects in a valid-ish state. Good. A customer. Brilliant. 2006. Martin Fowler said, try to name those methods, not a customer. Try to make those methods. Folks, do you understand what this is? It's a static method providing instances of your data objects filled as valid. Right? Who has such a class? Let me get some feedback. So let's make a half of you. All right, good. Here's an interesting idea from Martin Fowler. Try to name the methods in a more... this guy has an infinite budget. Can buy anything. We all know the guy. It appears in the requirements. You know Charles. Charles is that guy that bought everything on the planet, so it's absolutely super rich. And if you mention Charles, we all know about Charles. It's a persona. It can go back to the business and they talk about Charles. Hey, if Charles wants to buy a limousine without providing some credit card, do we sell it? Of course we sell it. It's Charles. What do you think? Now, the test data that we mentioned tends to grow very large and tends to be used by all the test classes in your system. So this means coupling. And then whenever there's coupling, there's pain. So this object mother can become creepy at some point. I'm not sure if you saw test data of 1,000 lines. Anyone? Test data of 1,000. Yeehaw, my friends, give me 5. Excellent. Good. Now, when this happens, you need to be very careful never to change the content of the test data class. Never to alter the contents of this method. Create new methods. Or get that customer and tweak it later, tweak it further. But don't change, because if you change anything in the test data, kaboom. All random tests can blow up because you just messed up with some state. Now, something else can happen with this object mother. It can get used in different areas of business, like invoicing and shipping. You might look at the customer return, and you might wonder, why does it have billing address and shipping address? I know why. Because it's used in these two domain areas. Isn't that cute? One first immediate step to fix it is to break the mother. Split the mother. Split the mother into welcome invoicing test data, shipping test data. I'm talking here with the monoliths, right? Another more brutal idea would be to break the entity. Oh my God. Welcome to bounded contexts. Welcome to modules, packages, and then maybe microservices. But you already knew that. You already knew the customer grew too big. And as a matter of fact, the biggest e-shop in Romania, they did that. They don't have a customer. They have an invoicing customer, shipping customer. Of course, right? With the details necessary for each domain area. So basically, tests tell you to make your structures more tailored for the problem you try to solve. Next one. You have domain logic filled with external API calls, taking weird parameters and returning DTOs, data transfer objects, of their API. And your core logic is full of DTOs with strange fields and details of calling that API that you need. So when you have to understand the test, you will have to understand the semantic of the API, or the meaning of this mysterious parameter that the library takes as the first argument. You will have to understand both your core logic and the semantics of the library or API when you're testing your core logic. That's bad. The solution for this is a concept called agnostic domains. If you have anyone heard of hexagonal ports adapters, clean or onion? That's it. Clean architecture. This is where this is going to. You are not supposed to call external APIs and manipulate foreign objects in your core logic. Instead, make adapters, wrap adapters over that externally, those external APIs or libraries, and only use your domain objects in your core logic and in your tests. Now, this next slide probably deserves more attention, about 2 hours. But if you are curious, there is a talk over there you can check out. The main idea is that the domain part in the core remains agnostic to the outside world, and it's surrounded by an application or infrastructure layer. Now, if the client will talk to you in terms of your DTOs in your API. The systems you call will return you DTOs of their API. Neither of those should enter the core domain, right? Or if you have a library over there which is just very bad, don't directly talk to that. Instead, wrap adapters over those, implementing an interface in the core domain. And I will stop here because if I start on this, I won't finish for the next 2 hours. So let's stop. Link if you want to know more. Good. The idea is that the core complexity remains expressed in on the domain model that you control, on your own data structures. That's very important to build both core logic and tests expressed in your concepts, in your world, not on some foreign DTOs. So what did we see until here? That tests will put pressure on signatures, make them simpler, and strive for more small structures and keep your core logic isolated from the outside world. Good. Next chapter. Unit tests give you hints on how to break complex logic. Let's see. Imagine a class. There are 2 examples here, pretty complicated. Pay attention. I promised a headache. I'm trying to, yes, fulfill what I... Imagine a class with 2 complex functions, one calling the other. If G is complex, you might think, well, given G is so complex, let me test it separately. So imagine you test G in isolation, by itself. The next thought is killing. The next thought goes like, when I will test F, do I want to avoid entering G? So if I run a test to F, would I like that test to actually go through G? Well, no, because I already tested G. So then you ask the question, can I mock a local method? And ChatGPT will be kind to you. Stack Overflow will show you the way. Of course, master. It's called partial mock. Don't. Unless you are tackling some terrible legacy code, don't go for partial mocks. It's the idea to mock a method inside the same class under test. It's hell on earth. You won't know tomorrow what methods are real and which are mocked in the production code. It's very, very horror. The hint that tests are desperately trying to give you is, master, don't you want to break the class in 2? What do you mean, break the class in 2? Yes, because I see F calls G, and both are complex. And guess what? F is more high level than G. What do you mean, more high level? It's the boss, right? F calls G, so G is just detail. So why not breaking the production code? Oh my God. So whenever you are looking into mocking a local method, stop and ask the question, can I reasonably break the class in 2? Like the facade and the domain service, or the orchestrator and the worker, or that detailed thing that I want to do? If the names are sound, break it. Because you just broke the complexity in horizontally, high level, low level. Make sense what I'm saying here? Do not call locally a method. Instead think, could I break them into classes? Can I find 2 names? If I can find 2 names, that's it. You found the responsibilities. So breaking class horizontally, but now I will show you how tests help us to break class horizontally. Just a moment here. I see people explaining on the side. Perhaps it's not clear. High level here will depend on the class low level. So you won't need any local method mocking. You will just inject here a good old mock, and you're done. You don't need any kung fu partial mocking spy stuck. stuff. Right? You're back on the clean design and everything. Now, imagine this code. Two f and g functions, both complex, but neither of them having anything to do with the other, completely decoupled, and both of them using some dependencies of their own. They are not using the same method. You see, one is calling A, one is calling B. And if both of these f and g are complex, testing them would require 5 tests for f, 4 tests for g. Now, this is where I need your brain. If you test f 5 times, you would need to do when then return on this method 5 times. Agree? 5 times copy-paste in the tests. And there was the principle, don't repeat yourself. So what you'll do, you will put that mocking, not in all these tests in here, you will draw it in the before, here. And you will do the same for G, because G needs the yellow one to be mocked. So in the before, you will end up with mocking for both F and G, correct? In order to avoid repeating that mocking everywhere. What's wrong with that? Imagine you have a failure in these tests. If you have a failure in the tests for F, you will desperately look in the fixture in this before, wondering what the hell is the yellow thing doing here? I don't need the yellow thing for F. You see? And those tests become unmaintainable, becomes a hell to understand what part of... Have you seen a before having 10 lines? When, then, anyone? Yes? Yes, I see some pain in the room here. So, a before which grows very large, trying to suit the needs of all the tests in the test class. That's a bad thing. It's called fixture creep. The setup of the tests grow. That's wrong. What you should do instead, the easiest way out is to break the test class in two. To have 2 dedicated test classes, one focusing on F, one focusing on G. And suddenly the before can be specific to all the tests in those classes. It's not like the place where you put something that anyone can use. No, it's something for you explicitly, right? Now, that's one way to have, that's the easiest way out. The more complicated way out, the more savage way to solve this is to actually break the production code. You saw that coming, didn't you? Why are those functions in the same class in the first place? I know why, because we have an application service, a controller. And anyone heard of a vertical slice architecture by Jimmy Bogart? The result of this breakthrough could be dramatic for your architecture. You might actually break your architecture completely and orient classes per endpoints. But this is wild. For now, in the small scope, the test will tell you how to break class horizontally. Nice. So we saw them breaking class vertically, horizontally. But there is one more thing to realize. Whenever you apply either of these ideas, whenever you think of these ways to break classes, you should ask the question, the classes that result, do they have a sound responsibility? Can I name them in a good name? Right? So basically, again, back to that paper from 2004. Do they have a sound responsibility or not? If they do, then okay. So these are hints that push you to break stuff. Okay. The third series of two more ideas here about functional programming, which is cool, right? Functional programming is cool. Unit tests will point you to using the principles of functional programming, which are pure functions and immutable objects. Who here has ever heard of pure functions before? Pure functions, that's amazing, like 2/3 of you, amazing, good. For the rest of you, a pure function cannot change anything, cannot change a field in an object, cannot do a network call to change anything, cannot do an insert, nothing. And given the same inputs, gives you the same results. In other words, it does not bring data from an external source of data. It just computes the results based on the parameters. You see, it doesn't go under the radar and let me just get something more from the database. No, everything is in plain sight, coming in through the parameters. Good. So it just computes a value. Just computes a value. That's a pure function. Now, to simplify this a bit, a pure function is not allowed to touch network, and is not allowed to change state. If you touch network, God forbid, what can happen? And again, do not change state. So what's the connection from this to us? Let's see. This is big. This is very big. Imagine a class, a chunk of code, chunk of code. A use case, a method, looking like this. Starting with find, call, and then boom, complexity. 20 tests just for this code in here. And then save, send. How many mocks would you need for this code? If you want to test this code, how many mocks would you need? 5. All the red things need to be mocked. 5 dependencies are mocked. Congratulations. Multiply this by 15, 20, I said, and you get what? You get hell. You get 20 tests looking like this. You will try Kung Fu. You will try Matrix. You will try before. Helper methods. Yeah, but the actual problem here is that you have complexity which is highly coupled to other dependencies, to other things around. The idea is to reduce coupling of complex code. Now, if you are very lucky, you might actually get to extract a pure function. Oh my God, a pure function. A pure function that just derives the result based on the inputs. If you extract that complexity, just have a look. ABC, the D needs to go out. You see? The D needs to go out. If you just extract that function that does the heavy computation, testing that function becomes amazing, becomes a pleasure, look, you just call the pure function with the ABC and you assert the state of the D. You don't need any mocks, you see? So tests without mocks. This is big and it doesn't fit this time frame. The idea is that any complexity you have, you pull into a functional core, into a place where only pure functions exist, and you push outside any connection to the outside world, database, APIs, any dependency, and any change to state. This is known as the imperative shell functional core segregation architecture. It's the idea to isolate the most complex parts of your code as pure functions. Let me give you more practical examples that I've seen in production. Compute price. Yeehaw! Right? Apply discounts. Compute loan eligibility threshold. 10,000 lines of logic in there, no connection to the outside world. All the inputs were given as a parameter. You see? These kind of stuff, super complex logic. Okay? All right. One more moment here. You have 4,000 unit. Who has here more than 4,000 unit tests in their project? I'm curious. 4,000 unit tests, if you know the number. Just a 10 of your. So you have 100% test coverage. Can you imagine that? 100% cost. Oh my God. Anyone has 100% test coverage? 100%. 99%. Look at the thing I wrote yesterday night. 99%. Perfect. And then you write code like this. DS comes from the discount service. Just have a good look at this method. DS, apply discounts, order, and discounts. And then the drama. A semicolon here, nothing before. This function here that you look at doesn't return me anything. Why? Why do you think this doesn't return me anything? Any wild guess? It what? It takes the order object, so what? It changes it. Oh my God. It will change the parameter state that I give it. Oh my God. This is dramatic. This is absolutely, oh my God, who does that? And then you compute the prices based on the updated order. And one day, young Victor, 15 years ago, changes the order of these two lines. And they had 100%. They didn't, but I imagine. Even if they had 100% test coverage, you still slip the bug in production. Do you see that? Because you computed the price on the order that was not updated yet. Damn! Right? What is this? This is called temporal coupling. When the order of execution of two lines matters for no obvious reasons, at least not for 15 years earlier Victor. So this is what you can have if you are using mutable objects. Of course, there are alternatives to test that. It's called paranoid testing. There is a way to check the order in which the methods were invoked. Don't do that. It's called in order. Don't do that. Instead, better to change the mindset and go for immutable objects. If this were immutable, if the order were immutable, the only way to change anything inside was to return a changed copy. Do you see? The only way is to return another value, another order, which has the prices updated. And now, if you try to swap the lines, what will happen? It will break the compilation. Think of it. So the data flow becomes burned into the compiled code. The data flow, you can't just, oops. It won't compile. Summary. What do tests teach us or tell us? If you ever have a stupid method and a huge test using mocks, ask the question, do I need the stupid method? Can I destroy it? If I can't destroy it, can't I test the whole thing together? Not in isolation, piece by piece, the whole flow. Can't I run one integration test, honeycomb testing, through everything, instead of mocking little parts? Signatures. If you call the same functions 20 times in a test, I swear to you, the name will be impeccable by the time you finish. And the parameters will be exactly what it needs. Because you will not stand to pour more and more garbage. It will click at some point, right? Dedicated data structures. Maybe leading up to cracking a domain entity into bounded contexts. Maybe. Wish you luck on that. And then agnostic domain. The core logic should not depend on the external world. Should be kept on your own domain model. Then, breaking complexity vertically instead of using a partial mock. Or horizontally, when you find that this method and that method need wildly different kind of mockings, and they still are in the same class. Why? Crack in between. And always think about roles, not just objects, right? Decouple complexity, let it be, make your core complexity use less dependencies. And if you go to immutable objects, you get for free protection against temporal coupling. Now, there is one last detail to put here. You see, it's important when you start writing your tests. If this is the time frame allocated for your feature, if you start testing here, whatever hints the tests will give you, you will say, it's Friday. I'll do it on Monday. And it dies like this. It dies like this. So it's too late. Whatever feedback you get from tests, it will be too late. That's why Kent Beck told us, try to think of testing earlier, because the earlier you think about testing, the earlier you ask the important questions, the better you understand the problem. The earlier design feedback you get, and you also get the courage to touch the code and to improve the design. Now, I'm not a religious guy. I don't believe in TDD, like some people out there say, hey, you either TDD or you're stupid. I don't say that. I'm just saying, start thinking about tests in the first half of your development time. Somewhere around here. We all need a bit of time to experiment a bit, yes, but once you got the point, or you think you got the point, write the first test. Or if you're lucky, if you're really lucky, call the business, hey, can we have a tea? 5 o'clock tea. We need to write a feature together. You and the business. That's amazing if you get to live this, but if not necessarily TDD, but at least early enough testing. Because if you write unit tests early, that would increase friction with stupid design. You won't survive to finish the task. The tests will kill you on the way, basically. Reading resources for later, you can pause the video afterwards and look. So that was it. If you want to join the community and engage more with us and chat and debate and counter us, there are way smarter people than me in this community. I know it. And it's a pleasure for me to talk about the topic, and I got debates, I got very fun. Be there. It's very fun. English, it's 1 hour after work. And with that, I thank you all, and I will wait for your questions here because the time is running out. So, thank you. Oh, and there is an article that I wrote about this if you want to brainstorm it slower. Thank you.